How to choose the right loss function in TensorFlow. Imagine you're building a machine learning model and want it to learn as accurately as possible. The secret ingredient is picking the right loss function. It's like choosing the right tool for a specific job. If you pick the wrong one, your model might not learn well or could even get confused. So, how do you make the right choice? Let's break it down. First, think about what kind of problem you are solving. Is it predicting numbers, classifying images, or something else? For predicting continuous values, like house prices or temperatures, you'll want a loss function that measures how far off your predictions are from the real values. Mean squared error is popular here because it penalizes bigger errors more. But if your data has outliers or noise, mean absolute error might be better since it treats all errors equally. Huber loss is a good middle ground because it behaves like mean squared error for small errors and like mean absolute error for large ones. It helps your model handle outliers without overreacting. Now, if you are working on classification tasks, where your goal is to assign data points to categories, the choice changes. For tasks with multiple categories, like recognizing different animals and images, categorical cross-entropy is often used. It compares the predicted probability distribution with the true labels. If your labels are just numbers representing categories, sparse categorical cross-entropy works well because it doesn't require one-hot encoding. For binary classification, like yes or no decisions, binary cross-entropy is the way to go. It measures how close your predicted probability is to the actual class. Some tasks are more specialized, like image segmentation or ranking, and might need custom loss functions such as dice loss or ranking losses. These are designed to handle specific challenges in those areas. TensorFlow makes it easy to choose and use these loss functions. The library has built-in options in the TF, Keras, losses module so you can pick what fits your problem. Remember, the loss function must be differentiable because TensorFlow uses gradient descent to train your model. If it's not, the model can't learn properly. Choosing the right loss function also influences how your model learns. For example, cross-entropy loss is great for classification because it directly optimizes probabilities. If your data is noisy or contains outliers, robust options like Huber loss can make training more stable. It's also good to match your loss function with your evaluation metrics. Sometimes, the metric you care about most, like accuracy, isn't suitable as a loss because it's not differentiable. Instead, pick a loss that guides your model toward the right behavior during training. In the world of artificial intelligence tools like ChatGPT, DALL-E, and Midjourney, choosing the right loss function helps these models generate accurate text, images, or other outputs. For generative models, combining multiple loss functions can balance realism and diversity. Ethics come into play too. Picking an inappropriate loss function might cause your model to underperform on minority groups or produce biased results. Understanding your data and task helps you avoid these issues and build fairer models. To sum up, start by identifying your task type, regression, classification, or something else. Match the loss function to your data and goals. Use TensorFlow's built-in options for simplicity. Always consider how the loss influences your model's behavior and fairness. Test your choices carefully during training to see what works best. This approach helps you develop models that learn well and behave responsibly.